I'm working on some spacers now that we're going to use to elevate our aluminum plate up off the fixture table in the mill. Go ahead and show you what we're up to here. So here's two that I've got one side finished. The idea behind this, if we come over to the VM, this plate's going to be flipped over onto the fixture plate. Yeah, this fixture plate, that's going to sit there, so it'll be sitting there like that to elevate it. I just thought that was a really simple solution, and these kinds of parts are extremely handy to have around, so every time you make things like this, you can put them in your toolbox and they'll be used for other jobs down the line there too. Took a piece of 1 3/4 of some 4140 that I had, drilled it 1/2 inch hole, turned it, parted off in the lathe. And decided we're going to use the TRM here to face them all to the exact same thickness. So I parted them 20 thousandths thick, and I want to face 10 thousandths off each side. And obviously on the second side, our goal is to have all the exact same thickness here. So we'll go ahead and start the next one. These two are faced on one side, so we'll go ahead and grab another one here. And I need to get that burr off there, so let me do that real quick. All right, we just used the Noga to get rid of that burr there so that whenever we set it down on our parallels here, that it doesn't stick up and hang up there. So tighten that in here. And let me set this camera down so I can tighten that up and bump it down. All right, chuck tighten, we tapped it down with our soft blow hammer. So it's just gonna be two tools there. We've got my tongue alloy, tongue force rec, 3/4 inch insert mill, and we'll face the top of it, and then we'll go around the inside and outside and chamfer it. All right. Optional stop is on. Let me turn that back off. Half-inch chamfer tool. Just making a 15 thou chamfer on the inside and outside to break the edge. There we go. Nice and flat. That tongue force rec always does an amazing job on the finish. It really is nice. So we'll just keep repeating that. So I've got it as op 1, op 2. Right now we're doing op 1, and then we got one more to face on one side, and then I'm going to switch over to op 2 here on the controller, and it basically will just repeat that. So we'll set it the good face down, and then take the last 10 thousandths on the other side. Go ahead and flip it over now, and we'll do the other side. I noticed that even with the chamfer tool, it had raised up ever so slight of a burr there. You could just feel it with your fingernail there. So I got one of my precision flat stones, and all you got to do is just a couple of licks on that flat stone, and that burr is absolutely gone. So we'll see what we landed on here. I was shooting for a 1/2 inch, and it looks like we've got 4 under 1/2 inch, so 0.496. Nice and flat. Looks like it's within 1 or 2 tenths being completely flat there. So that's without making any adjustments on cutter comp or I guess I should say tool wear, end wear. So we could definitely, since I've already got one finished, I want to make sure all 4 of them are the exact same thickness. But it doesn't have to be any specific thickness. I just want them all the same, on the same plane. So we're just going to bump all the other 3 in there, and they'll be hopefully finished at 496. All right, we got all 4 of our spacers done, so that's what it'll look like upside down. So now we can go ahead and get this set up, broken down, and we'll get the plate mounted directly on the fixture plate. Here I'm using my Starrett surface gauge and 196 indicator just to kind of see how straight this edge is. It's not super critical, but we're just trying to get it as close as we can. And it was within 5 thousandths, and tapped it around, and it looks like we're within 1/1000th there. This is sort of like a table saw cut on that edge, so it's not completely flat. That looks good right there. I've shown this a few times in other videos. This is a really simple way if you're going to put on the table or the fixture plate. This is just a really convenient way to line up a straight edge, some plate stock, if you will, on the CNC without having to put an indicator in the spindle and jog the table back and forth. To me, this is just a lot simpler right here. You have the pins that you push down so that you can run it along this edge, and the fixture plate was indicated straight whenever it was mounted in there, so you can use this as a reference. And just slide it along your part, tap it around, and tighten it up. Yeah, that looks great. I need to go ahead and locate our work offset now. Now what I should have done before I bolted it down was got my probe out and touched the top of one of the spacers that we machined, but I didn't think about that. But what we can do is I made a .496 gauge block stack up, which is the same thickness of those spacers there, because our origin for the Z is off the face that we already milled off the bottom of the plate. And so our gauge block stack up, I can feel it touching on all four corners. All right, so I know that's going to be really close there. I'd say within a 0.5 thousandths of being probably flat and parallel. So we're going to use this gauge block stack up, and we will just simply set it right here on the table, make sure that it's down flat, and we'll probe right off the top of that surface, and that'll be our Z0. And then we'll come to this bore here, and we'll just do a bore probe in there to find X and Y center in the hole. So that establishes our Z position there on our gauge block. So now we're going to go ahead and be gentle with this, and we're going to go to our bore. We're just going to do a hand wheel over there to it. All right, in our bore, we need to be down inside it, but I want to make sure that we're kind of centered on that bore first. Just use a rule here. It's pretty good that way. Let's see. Well, that's eyeball pretty darn close. All right, I think that's close, and then we're going to go down inside the bore. Something like that right there. Okay. All right, our part should be probed Everything looks good on the screen here. We'll get our gauge blocks out of here and put them away. So from here, I'm going to go through and verify I got all my tools correct. I've already installed all the tools, but I just want to verify it and make sure they're correct and bring you guys back when we're ready to start making some chips. All right, we've got you back at Fusion here, and we're just going to do a recap on what we're about to machine. So Op2 for our adapter plate. We'll go ahead and get started on our simulation here. We'll run you through it. We'll begin with our tool number 1, which is that 1/2-inch helical chip splitter in mill. And it's going to, you can see our 2-inch hole that we already made in Op1 is there. So that allowed us to line up on our part, get it probed in good. So it's just going to go through, this is a adaptive program that we're running here, our adaptive tool path. 175 thousandths radial load. And I think I've got it set at 5 thousandths per tooth. And hopefully this will work good. Once it's engaged on this material, I'll just have to kind of listen to the machine. If it seems like it's trying to slow the spindle down, I'll adjust my feed down. Most all these tools we're going to run at max speed, 10,000 RPM. All right, and so it's just going to continue to rough out that bore to, I believe it's 8.5-inch diameter in that center bore there. And then it's going to start machining the counter bore after that using the same end mill here. So it should be just about there. There we go. There's the counter bore. And it's going to step a couple of times because there is a 60 thou radius in that corner. And then once it gets that counter bore, it's going to finish machining the top face there. That'll be the finished face, this area right here. And the 4 corners will still be there. That's going to be our final operation. So this is our 3-flute finishing end mill with a 60 thou corner radius. It'll finish that ID there. And then I'm using my nice face mill there to put a nice clean face on that one right there. 2.5-inch face mill. Then we've got a 3/16 carbide drill to drill all of our 3/16 holes. Those are for the rivets. And then this is going to be a tap size number 7 drill for 1/4-20. It'll drill all those holes. And then now we've got another drill. I can't remember what size we run. 15/64, I believe, for the reamer. And then it'll ream it. Now we're on a chamfer. That's a 1/16 chamfer in that corner. It's going to chamfer this top corner there. And then that same tool is going to chamfer all of the holes on the top side there. That's our tapped holes. This is our reamed holes. And then I had to put in a smaller chamfer tool. This is going to be a 3/8 diameter because the 1/2-inch would have crashed into this wall right here. So we had to reduce the size of our tool there to, I had a 3/8 mill drill, so that's what we're using for that. And then the final operation is going to be our 1/4-20 tap. This is going to be a rigid tapping operation. I do have a tap specified for soft materials like aluminum. And this is my biggest worry, is just the tap itself. So I hope that we don't have any issues and it's going to tap it successfully. And then that'll be it. This is all that we're doing here on this side. And then I'm going to end up having one final operation where we're going to flip this back over, possibly. I'm not really sure how I'm going to fixture it yet. But what I'll probably do is just machine some kind of steel fixture that'll bolt down to the table in the middle. And then we'll be able to set this down on it, register it on this bore, and then be able to clamp it on the inside. And then we will come around the outside with the end mill and cut the remainder of this material off. And then that will bring it to the finished diameter on the OD there. All right, so we're ready to start making some chips. I want to show you guys the end mills that we're going to be using for these operations. But we're going to start with this right here. These are all helical end mills. So 82142 is the part number for this. This is the same end mill that I've been using to rough out our drill indexes, and I can't recommend it enough. It is such a great cutter. So 1/2-inch diameter, 3-flute, and it's the chip splitter style. So when you've got to really focus on your chip management because they're building up in the machine, if you'll go to these chip splitter like this, it'll really help you manage the chips piling up. So this is what we'll use to rough out the hole. And then whenever we go in there and finish that center hole, we're going to be using this one right here, the 81452. It's basically the same end mill as the chip splitter without the chip splitter grooves cut in there. okay, 10,000 quarter radius, but we'll use this one to finish that bore. And then this third one here, this is a bull nose, so it's got a 60,000 corner radius. This is what we're going to be using to finish some of our surfaces down in there. Like over here on this pulley, this end mill will come in here and finish this face here and put the 60,000 corner radius in there as well. So that's when this one will be coming into play. But anyway, I wanted to show you what cutters we're going to be using, and we'll get over to the machine and get started now. I've got the program all loaded up. I did a simulation here and everything looks really good. It should be good to go. I've been getting my coolant nozzles adjusted for every tool that we're going to be using, just to be sure that every tool is going to get some coolant on it. So it's going to make a mess, but I got to run it with coolant on there. Nothing I can do about that. We're going to get the best video we can and share with you. So let's get started. All right, I think we're ready to roll. Since this is the first and only part I'm cutting of this, I'm going to be sure, and when the tools are coming down, I'm going to check my clearances, and once I know that we're good to go, things are where it needs to be, we'll give it 100% on the send feed level. All right, here we go. Slow everything down here. That coolant, man, if I could just get the coolant to turn on when the tool's down there closer, it wouldn't get all over the camera. Just want to make sure it's good here. All right, I think we're good to go. Coolant engage. This is 50%. That's 80%. Looks like it's handling it. All right, there's 100% feed rate right there. Got the spindle loaded up around 45%. All right, I'm gonna halt it. Let me see if I can get the camera cleared there. Maybe that'll help for a few minutes. Checking my clearances here. All right, this is making our contour pass around that bore. Now we're on the face, the counter bore. Okay, now we're moving on for our face mill. We're going to put our finished cut on that face. I forgot to put through tool coolant on that particular face mill right there, but we're just going to roll with it. Make 2 passes, 10 thousandths per pass. All right. Moving on to our 3/16 drill. Watching our clearances there. Okay, I think that's it. This should be our number 7 drill, tap size for 1/4 20. Okay, that looks good. Let's kill it on. Okay, this is going to be our 15/64 drill bit. This will be a drill size for our 1/4-inch reamed holes. Looks good. All right, next up is our 1/4-inch reamer. All right, that looks good. Now we're on to our chamfer. It'll be the 1/2-inch chamfer. It's going to cut the chamfers and chamfer the top of the holes. All right, let's see. We need to go ahead and feed it down. Yep, okay. Gonna make 2 passes around that lower chamfer. I just wanted to make sure we had a good finish on there instead of cutting it all at one time. Somebody is outside with stadium level speakers on. I don't know if you can hear that. All right, cutting the chamfer on that upper edge. Chamfers. Chamfers for the 4 reamed holes. Now we're going to grab the 3/8 mill drill to chamfer those lower holes. Okay, looks good. Okay, last up, we got our 1/4-20 tap. I'm over here tensed up. Oh, there it goes. Man, you got to be kidding me. It just broke the tap. Why would you do that? Why would you break a tap off in a finished part like that? I'm just gonna let this, it's all the way at the end. I'm just gonna let it finish off. So this is really disappointing. That means I'm gonna have to make another piece. Unless I can get that tap out of that hole, and then I can, if I can get that tap out of that hole, I can save it and just tap the other ones with the flex arm. That was a specified tap for aluminum right there. All right, that's the end of the program right there. Everything was going so great until the very last tool, right? What a disappointment. Absolute disappointment. Everything else looks beautiful. All of our finishes look good. So I guess I'm gonna have to see if I can get this this broke tap out of there. That thing, it's all the way down in there, so I don't know. That one's gonna be a chore to get out of there. I'm trying to put a smile on my face instead of showing the sheer disappointment that I have right now. I'm really upset because we nearly had a finished part. I know we still got to finish the outside, but all of those things that we just machined, everything went beautifully except for the tap. So that was the third hole, and it should not have broken that tap. We were using the proper style of tap for tapping aluminum, spiral fluted tap. So it's obvious that it loaded up inside there. The chips weren't evacuated like it should, and it loaded up, and it doesn't take a lot of material to load up a tap and cause too much pressure, and it'll just snap it right off, which is what happened with us here. So really disappointing in that. So I think I'm just going to take it out from here, and we'll go over to the manual mill, and I'm going to see if I can get that tap out of there. I might be able to drill it. I've got some carbide drills. I'll have to look and see. I may have to buy something, I'm not sure. But my first attempt is going to be to see if I can get that broken tap out of there. If I can, then everything's good. And then we'll simply use our flex arm over there, and we'll just power tap the rest of them in the flex arm and not worry about in the machine here. Another possibility that I know that we could do in the machine here is a thread millet, but that's not the approach that I was going to take with this job. Rigid tapping is the quickest way to get the threads in there, and it should work. So I wanted to go with rigid tapping because I felt confident that it was going to work, and that's why I ordered the right tap for tapping the aluminum. But it failed, and so far this is kind of at a failure point right now. So I got to see if I can save it. If we can get that tap out, even if I mess the threads up a little bit trying to get the broken tap out, worst case is that I can put a little thread insert in there too in that one hole just to make sure it's got good threads, and then finish tapping the rest of them. So I think at this standpoint right now, we're just going to call this video complete, this part of the job complete, and then we'll pick this up once we start working on that tapped or that broken tap and see if we can get it out of there. And then if we can, hopefully we'll move on. My last setup was going to be to take this and set it on this registered fit here in a fixture and get it bolted on the inside with an inside clamp, and just use our cutters to come around the outside and finish that OD on there. So, but that was going to be the last phase of the project. So anyway, I'm going to sign off for now because I've just I've had enough for one day. I'm gonna move on to some other things and get my mind off of this, and then we'll revisit this and see if we can get it fixed. But I hope you enjoyed watching the video. Thank you for following along, and come on back, and I'll let you know if we prevail or if we've got to make a whole new part again. All right. It's been a few days since the last video where I was working on getting the broken tap out, and I thought I would catch you up to speed on where we are. This is a new piece of stock that I purchased, got it in, and drilling the broken tap out was starting to cause more problems than it should have. and I decided to just take a step back. Let's just get another piece of stock in here, which we did. We've already got these programs proven, and I just wanted to just machine another one. So that's where we are right here. This side's finished. I just need to take it out, get the vise off, and then we will take this, flip it upside down, get it centered, finish the other side, which you have already seen. So I'll bring you over here. Shop's looking a little bit different since the last video. We've got Dad's old welding table in here now. This is something that me and Abby's been working on this week. Is we've been getting machines moved out, we've been getting tools sorted, and this is something that I wanted to get out as well. So we got it moved down here, and I'm trying to get back on this project to try to get it completed. So this is where I'm at right now. We'll talk more about this stuff later. I just want to focus on this job. So this is the one that had the broken tap. It was this hole right here. And the tap was still down in the bottom of the hole, and I was worried that it was just going to cause an issue with the bolts not going down in there or the coil not going down in there right. But I did order a set of helicoils here because I didn't have any more, and I used Dad's install tool right here. It worked perfect. We've got a helicoil in there, and now we have the hole is back on size. This is one of the actual bolts that is going to be used for the adapter, and it screws in there just like it's supposed to. So this might still be a good part right here, but just because it was giving me such fits and it was really starting to annoy me and bother me, and I wanted to make sure we had a good part, so I decided bite the bullet, get another piece of aluminum and start over. And that's what we've done. So we're gonna have two of them now. I'll go ahead and continue machining this one. This one will be our first setup, and it'd be a good way to prove our next two ops that we're gonna be doing. And get this machined, and then ultimately that one that's in the VM will be the one for Tim for his bike, and then this one will just be a sample for me to have here. All right, but that's where I'm at right now, and I want to try to get this thing done. So we're going to keep pushing forward. Go ahead and get the second side machine on that one, and then when we get to that point, I'll bring you guys back. So I'm going to change my program slightly. I'm not going to do the rigid tapping. I know the machine will do it. In hindsight, this is what I should have done. I should have considered thread milling that. And I know that I can still thread mill that, but that would be another tool. I don't have a thread mill for 1/4-20, and I don't want to practice on the part that I'm working on. I need to get a thread mill. I need to get a piece of material in here. I need to practice it, prove it, and understand that I can do that properly and implement that on future jobs going forward. I really do want to try to do some more thread milling, but I don't want to start now on this job. I have a flex arm right there that I know will help tap these holes, and it'll get it done super fast. So that's what I'm going to be using to tap our holes this time, and we'll worry about thread milling on some future jobs and projects. I need to get a couple more of those in here, so I got some in the toolbox. So I'm going to work on this. We'll bring you guys back once we're ready to start machining the rest of it. I got a plate burned out at the welding shop, piece of steel. I'm going to put it in the lathe. We're going to do a little bit of turning on it. We're going to machine a fixture that we can bolt it down in here in the table, and then we'll be able to take our aluminum here and set it down on top of that fixture. It'll center itself up. We'll have a couple strap clamps to hold it down, and then that's what we'll use to hold it to machine the outside corners off of this piece and finish the OD. That's where I want to bring you guys back whenever we do our power tapping in, machining the fixture, and getting to the next op over here on the VM. Just wanted to give you guys a progress report. This is the second plate, successfully machined. Everything's good. All we got left to do is tap the holes, which I already said we're going to do in the flex arm. And I did measure our counter bore there with the inside mic, and it's spot on just like the first one, which is, again, one of the things that I love about the CNC is the repeatability. But anyway, so this is finished. We'll take it out. We'll go get the holes tapped, and then we'll move on to our next fixture. So I went ahead and used my first workpiece here, the one that I had to put the helicoil in to test it on the flex arm here. Everything is working fantastic. Flex arm's doing its job. Kaeser's over there pumping nice clean air for us to run the flex arm and blow it all off. And it's doing fantastic. So we finally have some luck with our tapping here. Here's one of the bolts that's going to go in there. It's running in there nicely. So this is the hole that's got the helicoil. These are our first 2 rigid tap holes, and then the rest of these were tapped here with the flex arm. So now that we know we've got a good system going, we'll go ahead and grab the new workpiece. We'll get it mounted over here just the same, and we'll go ahead and get these holes tapped next, or those holes tapped next anyway. The fixture table worked out perfect here. I was able to use my same 10-inch bolt circle here, or 10-inch spacing anyway. I'll go grab the other one and we'll get started on it. Come on now. It's definitely not a clearance hole. I just drilled it 1/2 inch because that's one of my carbide drills is a 1/2 inch. So really not a lot of clearance in them holes for the bolt. That is it. So we're using our anchor lube for this. And what I'm doing, what I felt comfortable doing is just dabbing a little bit of it just down in the hole. And then each time we go to tap it, we'll go ahead and dip it in the anchor lube there as well. We're using our high gear on the flex arm for this. Just go ahead and dunk it a little bit. Once it bottoms, it'll clutch out there, and then we just reverse it out. Blow the chips off, go to the next hole. I feel so much better now that this part is tapped and we didn't have another broken tap to deal with, and everything is working great. We're gonna go ahead and blow this off. I usually like putting a towel or a rag over where we're blowing the oil and the cutting fluids off, just to help kind of contaminate it. Contain. What'd I say? Contaminate? I'm sorry, I meant contain it. All right, here's one of our bolts that will be used. Got a good fit on the hole there. All right, we can now move on to our next phase of the build now. Now we have our holes tapped. I'm gonna focus on the fixture. This is gonna be the last fixture and setup. We need to machine the outside, so I've got that steel ring that I need to machine that this is gonna register on, and we'll be able to bolt it down to the fixture table in the mill and be able to clamp it right here on the inside. So that's what we're gonna start working on next now. They agree too?
I'm sure they do.
Man. Yeah.